everybody. The purpose of this video is to get you some solutions to this quiz, this little meme quiz about the guy with the hard hat and the dirty face and the complaining about about getting paid not enough to get by. First question is, what message is the meme attempting to get across? I was pretty flexible. Oh, little typo there. That should say right a sentence or two. I was looking for, I mean, he kind of says it in the end here. How can the people of our country advance in life like this? The more kind of pointed, I think, point is that inflation of goods costs have outpaced earnings. $10 an hour to $17 an hour sounds like less than, for example, $300 to $1,400, and you'll see that it is. So the question is, is it meaningful? And we'll get to that, of course, during the solution of all these problems. So then I wanted you to figure the average inflation rate for each of these items. And I only had you do 4 because, you'll see in a second. So what I'm going to do is I'm going to do 2 of them because all the math is the same regardless of which ones you choose to do. So I'll do the $10 an hour installing the air conditioning one first. Actually, we'll do them all, because once you do one, you see the math. It's just a matter of plugging and chugging the new numbers in the same expression. So you got to think back to the way we did this in class. Let me open up what's the best way to do this? Is it Word? Probably. Oh, goodness, I got a lot of documents open right now. Let me just start a new one. That might be easier. Word. Okay, pull it over here. The big idea of exponential growth, things growing or decaying exponentially, is you have an ending amount, and that's equal to some starting amount times some rate to a certain number of compounds. And that's rats, let's make it rate, and then compounds is an exponent, so I'm going to make that a superscript. So if you know the starting amount and you know the ending amount and you know the number of compounds, you can figure out the rate. And this is what we were doing in class with inflation, which is literally exactly what you're going to do on this quiz. So let's just look at the math for the hourly wage. So the ending amount was, I think he said it was $17 an hour. Oops. $17 per hour. And then the starting amount was $10 per hour. And then the rate is unknown. We don't know what the rate is, but we do know there's 40 compounds, right? It's gone 40 years. Let's go back to the quiz and look at that. So 78 to 2018, 40 years. $10 an hour increased up to 17. Now the idea is, if it paces with inflation is exponential, so we're going to apply that rate exponentially 40 times. Now in class, the way we did this, and I'm going to go through it a little bit quicker on the quiz because you've already done it in class a few times, is you have to figure out how an expression like this over here gets built. Like, if you were the rate, what would you do to that number first in this expression? And the discussion we had was, the first thing you would do is raise it to the 40th power, and the last thing you would do is multiply it by the $10 an hour. So the first thing you have to do is divide both sides by the $10 per hour to get rid of it. So you divide $17 an hour by $10 an hour, and you literally just get 1.7, which I got to make a non-superscript. The units disappear because you divide them off. And then you're left with equals rate. Well, I'll just copy it down from here. So that was the first step, was to divide by the 10. The last thing to do is to undo the 40th root. So you literally have to just take the 40th root. This, again, we did this in class. You take the 40th root of 1.7. So I'm just going to type that out, because the way I did it in class is, I think the way a bunch of you are, 40th root of 1.7. Because the 40th root of this side leaves you with just the rate. And the 40th root of 1.7 will be whatever the rate is. Now, I'm going to come over here. I'll just open up another window here. And I can literally just type 40th root of 1.7. And I get 1.01335, blah, 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 blah. The important part is right there. 1.013. That means 1.3% inflation over that time period. So if something was $10 in 1978 and grew to $17 in 2018, that means it grew at an average rate of 1.3%. The one, remember, the one out front simply means we never got smaller on average, it got larger, and the 0.013 is 1.3%. Now we can do the exact same math on the other things. The truck that was 6,800 went up to 40,000. So watch this badassery. You can literally you can do this all at once. 40th root of 40,000 divided by 6,800. So see what I did? I just put the whole thing in one mathematical expression. There you go. 4.5%. Oops. The one again is the inflation, 4.5%. So in other words, looking at it right now, before we go any further, the rate of pay, assuming these numbers are correct, which we have no source to know whether these numbers are actually correct or not, but assuming they're correct, 1.3%, and the cost of the truck is 4.5%, that means the truck grew at 3 times the inflation of his pay. The rent was $300 a month. Now it's $1,400 a month. So we can just come in here and change the ending amount and the starting amount. Make it 300 here. And looks like rent grew at 3.9%. All right. So there's your. And then the one that I was getting a lot of questions on was food. Food costs 7 times more. And a lot of people said, wait a minute. Food. There's no food value down here. Well, the question really is, or the statement really is, you don't need to have a food value because you know it's 7 times more. So what some people did, which I thought was pretty clever, was they made up numbers. They said, okay, let's assume food costs $2 in 78. 7 times that is 14. So what they would do is they then come in here and they $14 divided by $2, and they'd end up with a rate of about 5% increase in food. Well, other people used different numbers. They said, well, I'm gonna assume that food was $20 in 1978. That means it's 140 now because it's 7 times. And when you realize, oh, it's still 5%, it's because it doesn't matter what number you start and end with. If it ends up being 7 times more, you're always going to be taking the 40th root of 7 over 1 or 7, which means you're always going to get 5% no matter what you start and end with. It doesn't matter. Mathematically, since it's dividing, the starting and end values don't matter. All that matters is the ratio, which is kind of a neat. That's why I thought it was kind of a fun problem. So there's your rates. The wages went up by 1.3%. The truck went up by 4.5%. Rent went up 3.9%, I think, if I remember correctly. I don't remember actually. You can go back and watch the video again. And food was 5%. What was the actual average rate of economic inflation? So there's a couple ways you can do this. One way is just to use a CPI calculator. And then do exactly what we just did. Make up a starting value in 78, see where it goes to in 2018 and reverse engineer it. But one of my students, either this term or last term, actually Googled average rate of inflation 1978 to 2018, even though I spelled everything wrong. And what's interesting is it popped out 2.44%, which is actually not correct. Just so you know, that's not correct. If you look at the link, it tells you in here, here's your CPI calculator. I'll show you what the correct answer is. If you read this, according to the Bureau of Labor Statistics Consumer Price Index, prices in 2018 are that much higher than 1978. And a lot of people erroneously put that as the average rate of inflation. That isn't the average rate of inflation over 40 years. That's what percent more expensive things are now than they were then. That's not the average rate of inflation. The dollar experienced, here we go, an average inflation rate of 3.43%. Now, please notice the first Google search returned 2.44. That was the inflation rate in 2018, not the average from 78 to 2018. So if you were unsure about which one of these to use, another way to do it is just to use the inflation calculator, which this would be the same one that I would use if I Googled it. Pick a start year of 78 and end year of 2018. I'm going to put $1 in just because it makes the math easy. That would inflate up to, here we go, $3.85. $3.85 in 2018. $1.385. Then you can literally just go back and do it exactly the same way we did here, except you're going to start with $1 and end up with $3.85. Starting, ending, you're going to do the division. What's so nice about using $1 is it just divides the 385. And then you're going to take the 40th root of 3.85. And we'll use that. We use Google to do that. I got way too many windows open. Where was I here? I don't know where I was. I'm all over the place right now with my windows. Hang on, let me find it. It's going to be here. There we go. And then we just simply take the 40th root of 3.85, and look what you get. You get 3.43%, which is exactly, if you go back to the last page, is what they said it was, 3.43%. So, I mean, there's a couple ways you can do that one. That's why I said you can Google it if you want. The trick with Googling it, as I think, as we move forward in the 21st century, the trick with Googling it is making sure you know that you're actually reading what you get correctly, which unfortunately is one of those things that I think is a lost art. So hopefully you're learning a little bit more about critical reading and critical thinking and debunking in this class with me. And the last question is the meme's message correct in your opinion? And I lots of possible answers for this one. One of the answers I saw, a lot of the answers I saw were, we think it's correct because the cost of the goods is greater than the cost of paying for the goods, which, or the rate of increase of the goods is greater than the rate of pay, which I thought was a great answer. A couple of you picked on the actual data saying, well, yeah, the meme seems to be true, except for the fact that we don't know if those numbers even are correct, which I thought was another great answer, challenging the data, the veracity of the data. So lots of good answers there, and I usually get tons of good ones for questions like this, where we ask you to open up and kind of what do you think kind of questions, as I like to call them. All right, my friends, so that's quiz 5, and yeah, hope it helped, and we'll see you in class.